All right, so this is going to be the second screencast for going over this bellwork. We did 1, 3, and 4 on the first screencast, and we're going to do 2 and 5 right now. So on number 2, here's the situation. In an evaporating dish, you have some copper powder. So 63.55 grams of copper powder is heated. That's supposed to be over a little lab burner flame. But anyway, so the copper powder is heated, and it says the powder turns black and 79.55 grams of copper oxide is produced. And the question I have is, does the reaction obey the law of conservation of mass, and explain? Well, at first glance, you might want to say, no, it doesn't obey the law of conservation of mass because you've got 63 grams here, 79 grams here. But there are actually some things that you need to think of that weren't specifically mentioned in this situation, and they're important. So you begin with copper powder, and you end with copper oxide. So obviously copper has reacted with something. Oxide refers to oxygen. So copper has reacted with oxygen. But nowhere in here is mentioned oxygen. Well, that's because the oxygen that it reacted with was actually pulled out of the atmosphere as the reaction went on. So you wind up with a larger mass here than you started with, just simply because the mass of the oxygen that was involved we didn't weigh because it was part of the air. So does this chemical reaction obey the law of conservation of mass? Yes, it actually does. If you will remember that the extra mass came from the oxygen in the air, which we did not weigh. All right, so make sure that you have the explanation here, because guys, the law of conservation of mass is going to apply to any chemical reaction. So this chemical reaction has to obey the law of conservation of mass just like any other one, if it's going to be written properly. Okay, next question is, how do you know that a chemical reaction has taken place? Well, remember that you have those 5 pieces of evidence: color change, temperature change, odor change, gas bubbles, formation of a precipitate. Which one was described here? There was a color change because the copper powder turned black. Okay, so make sure you've written that down. Then you've got this next question. It says, write the balanced chemical equation using coefficients and masses in grams. Okay, so we're going to write the chemical equation first. Remember that we have copper powder at the beginning, and it's actually reacting with oxygen in the air. So let me show you what the reactants and products are. All right, so you have copper powder reacting with oxygen gas. This is oxygen in the air. Actually, the oxygen atoms hang around in pairs, so you have to write it as an O2 molecule, and then that produces copper oxide. If you look carefully at the way that this is currently written, this is not a balanced chemical equation because I don't have the same number and kinds of atoms on both sides. I have 1 copper on the reactant side and I have 1 copper on the product side. But on the reactant side I have 2 oxygens, whereas on the product side I only have 1. So that has got to be fixed in order for this to obey the law of conservation of mass. I can only fix chemical equations with coefficients. So I'm actually going to add a coefficient of 2 in front of copper oxide, and that fixes the oxygen. But then I have to come back over here to the other side and fix the copper. So 2 atoms of copper react with 1 molecule of oxygen gas. Remember, 1 molecule of oxygen gas has 2 atoms, producing 2 molecules of copper oxide. Okay, the other thing that I've asked you to do on this question is to deal with the balanced chemical equations using the masses in grams. So I have, if you'll read the question, 63.55 grams of copper. I don't know how much or how many grams of oxygen gas are produced, or are used. And I wind up with 79.55 grams of copper oxide. Now, the law of conservation of mass says that matter cannot be created or destroyed during an ordinary chemical reaction. So whatever mass I have at the beginning, I have to have the same mass at the end. So working backwards, if I have 79.55 grams at the end, that means I had to start out with 79.55 grams total at the beginning. So that enables me to figure out how much oxygen gas was used. So if I know that the total on both sides has to be 79.55, and I know the mass of the copper, then I can figure out the mass of the oxygen gas that was pulled out of the atmosphere as part of this equation. So I wind up with 16 grams of oxygen gas. Okay. All right, we're going to do something similar on the back for number 5, but there are some mistakes on the masses, so I'm going to give you the new masses before we actually do the problem. All right, number 5 says propane burns in the presence of oxygen to produce carbon dioxide and water. So here's the formula for propane. And I've actually already balanced the chemical equation using coefficients. So 1 molecule of propane plus 5 molecules of oxygen gas produces 3 molecules of carbon dioxide and 4 molecules of water. All right, in grams, here's your situation. Okay, 44.10 grams of propane plus 160 grams of oxygen gas produces 132.03 grams of carbon dioxide, and I want to know how many grams of water is produced. So once again, the law of conservation of mass says that matter cannot be created or destroyed through ordinary chemical reactions, and that means that however much I start with, I have to have the same at the end, not only in the number and types of molecules, the number and types of atoms. I have to have the same numbers and both types on both sides, but I also have to have the same mass on both sides of the chemical equation. So whatever the total is here, that's the same as the total on the product side. Okay, so I'm going to add my 2 reactants up, and I get 204.10 grams. So that's the total mass of the reactants. So that also has to be the total mass on the product side. So if I know my total is 204.10, then I can find this missing number if I will subtract out the number that I am given on the product side that I do know. And I come up with 72.07 grams of water.